Now, when using lifecycle hooks like ng-on-init, there is one potential problem. It's easy to introduce a typo, like here, the lowercase o, which is wrong, and you won't get any error because, of course, you can define methods with any name of your choice in your classes. So defining this method here is not wrong. Angular just won't trigger it. Which is why if you save that, you might have an error in your application that can be tricky to debug. Because you're not getting any error message here, and also not here where you ran npm start, but still the server status will now never change, because the interval was never set up, because this method was never triggered, because you had the typo in here. To avoid hard to debug problems like this, it's recommended to use a specific TypeScript feature that is embraced by Angular when it comes to these lifecycle methods. You can add the implements keyword after your class name, and that's now a keyword that does not exist in vanilla JavaScript. It is a TypeScript feature, and it's used to implement an interface, which in the end means that you use an interface, which is another TypeScript feature which we used before to define the shape of an object type. And you can implement interfaces like that in your classes to force your classes to have a certain shape. And Angular exposes an onInit interface, which you can import from @AngularCore, and which you must import from there. Now, onInit is an interface, as you can tell. And by implementing it into the class, we force ourselves to implement it correctly, which means we need to add all the methods, for example, that are defined on that interface, so that are defined by the Angular team for that interface. And here I'm now getting an error because I'm not implementing this interface correctly. If I take a look at that error, I see that the property ng-on-init is missing in my server status component class. And it's required by this onInit interface. Now, of course, I have ng-on-init here, but I wrote it incorrectly. I got a typo. As soon as I fix that, and I have the capital O again, this goes away. And that's why you should implement those interfaces to protect yourself against unwanted typos like this. With that, again, if you save that, everything will work the way it did before, and eventually the server status will change. But now with help of ng-on-init, implemented with help of this interface. Now, as you can tell, if you take a look at the official documentation, Angular got quite a few lifecycle hooks, quite a few methods you can add to your component classes to have them triggered by Angular. And in that documentation, at the bottom of that page, which you also find attached to this lecture, you also find some nice diagrams that show you the order in which those lifecycle hook methods are invoked, depending on whether a component is rendered for the first time or if it is just updated because some input data changed. But the best way to understand this order is to see it in action. That's why I prepared a brand new project, and we'll get back to our main project thereafter, but I prepared this project, if you want to call it like this, because this is a demo project where I have one simple lifecycle component, where I just output some dummy text, which implements all these lifecycle interfaces and therefore all these lifecycle methods. And then in there, I simply log to the console because that, of course, is a great way of seeing in which order these hooks are executed and when exactly these hook methods are executed. Now, you find this project attached, and you can, of course, then download it, run npm install, and then npm start to start it. And if you do so, you should see this screen here. And there you can toggle the lifecycle component visibility so that this component appears or disappears. And you can also change the lifecycle component text so that this text down here, and therefore mostly this number here, will change every time you click this button. And that's all happening due to how this lifecycle component is built, that it receives an input, and that in the app component, I'm then rendering it conditionally based on that lifecycle component is visible state property here, which is updated whenever this first button is clicked. Here in this onToggle lifecycle component visibility method. And here I'm not using signals, but the behavior would be the same if I would. So that doesn't matter here. Now, therefore, in this application, if you open your browser developer tools, you'll see a bunch of logs. And I'll reload this to clear my logs. And you'll now see that if you click on Toggle Lifecycle Component Visibility to show this component for the first time, these are the logs that are being output, and here we also see the order in which these different lifecycle methods are executed. It's also worth noting that for the ngOnChanges lifecycle hook, I'm also logging an argument that is received by that lifecycle hook. This changes object, which will be passed into this lifecycle method automatically by Angular. Because all these different hooks, of course, have different purposes, and I'll get back to those purposes in just a second. This ngOnChanges hook, for example, is executed by Angular whenever the input that is received, or the inputs, if it's multiple inputs, that are received change. So in this case, whenever this text input changes. And Angular then automatically produces a changes object, which gives you more information about the input changes that happened. We can see that here. If we expand this object, we can see that it contains one property per component input. And here I only have one input, the text input. That's why in my case here, I only have one property here, the text property for this text input. And if we expand that, we get some information about that input and how it changed. We can see the currently assigned value, so the latest value that was received here, which is that text that's also showing up on the screen. We also learn whether it's the first change that occurred here, so if it's the initial value in the end, and that is the case here. And if it would not be the first change, we would also see the previous value. Or if we had assigned an initial value in the component, we would see that previous value here as well. And you get this information for all the input properties that you do add to a component. And whilst you might not need that information too often, it can sometimes come in handy if you then have some component internal state, so some other property in the lifecycle component, which you want to change whenever the input value changes. You could then use the ngOnChanges hook to do that, because that hook gets triggered whenever the input changes, so you could then calculate some new component internal state based on that and based on the changes information you're getting here, for example. But that's the ngOnChanges hook. As you see, there also are some other hooks that are executed in this order. And before we now explore in greater depth what these different hooks are about, I first of all want to show you the ngOnDestroy hook in action, and also show you which hooks get triggered if we change the component without making it disappear. But let's start with the disappearing case. For that, I'll clear the console, and I'll click this Toggle Lifecycle Component Visibility button again. And that removes the component from the screen. And as you can tell, the ngOnDestroy lifecycle hook method was executed. Because that is a method, a lifecycle hook method you can implement to do some cleanup work, for example, because it will be executed right before the component instance is about to be destroyed. For example, because the component was removed from the screen, because it was rendered conditionally, for example, as it's the case here. So that's a great hook for doing cleanup work, and we'll see it in action in the main project soon. Now, if I clear the console again and I render the component again, I again got all these initial hooks that are executed. And if I now clear this console and I change the lifecycle component text, you'll see that we also got some hooks being executed, but not all the hooks we saw before. For example, ng-on-init or the constructor are not executing again. But ng-on-change is executed as a first hook because the input value, this text which is output here, changed. And we get that change information, therefore, the current value, but now also the previous value, which was used before, in case we needed that. And then also these hooks. And therefore, it's of course interesting to understand what all these different hooks here are about. And here it's important to understand that the constructor, so this constructor method here, is just the standard class constructor and has nothing to do with Angular. Instead, in JavaScript and TypeScript, you can add such a constructor method to every class you define. You don't need Angular for that. This is a standard JavaScript feature, and you should indeed not use the constructor for any complex component initialization work. Also because in here, not all the component information is available yet. For example, if you log the text property here, which is set as an input here, so which receives the data from outside the component, if you log that here in the constructor, you will see that if you reload and render this component again, you get undefined initially, because the input value won't have been received in the constructor yet. So if you would need to do some initialization work based on some input values, you couldn't do it here. And indeed, it is considered a bad practice to do any complex component initialization or setup work in this constructor function. You should only do basic class initialization work here, like set some initial properties. But if you need to do anything more complex, like for example send an HTTP request, which we will do later in this course, you should do that in ng-on-init. And here you also have access to any input property values. So if you log this text property here in ng-on-init, you will see that if you log this all again, once ng-on-init executes, this initial text value is available. So this text property value is available. And it is therefore ng-on-init where you should do your main component initialization work. Now ng-on-changes, as I explained before, executes whenever the input value changes, and you can use that hook to, for example, update some component internal state, so some other property that you might need to manage, which might need to change as input values change. You could do that here. And then we got these other hooks. What are those about? ng-do-check is related to Angular's change detection mechanism. And in the end, ng-do-check is invoked by Angular whenever Angular thinks that a UI update might be needed. So whenever it detects any event or anything anywhere on the entire application, so not just in this component, but anywhere in the entire Angular application, that could lead to data changes. So this hook gets invoked a lot, and therefore you are discouraged to use this hook unless you need to, because whatever code you execute in here will run a lot. You might need it for some very advanced niche use cases, but often if you feel like you need it, there might be a better alternative solution available. But still, it is important to know what this hook is about. And then we get these content init, content checked, and view init and view checked hook methods here. And what are those about? Well, first, it's important to understand what the difference between content and view is and how it relates to an Angular component. And let's